Mediator design pattern is one of the widely used behavioral design pattern. Let's say a passenger wants to book a cab. He can directly go and look for a cab, and the cab may or may not be available. This type of architecture is called tightly coupled architecture. Instead, the passenger can ask a mediator. In this case, a mediator can be Uber or radio taxi, where the passenger requests for a taxi and the Uber checks if any driver is available and assign it to the respective passenger. Let's jump into code and check how to implement it in Java. ATC, Air Traffic Controller, is a commonly used example for mediator design pattern. What ATC does is, it informs flights that whether the runway is available for landing or takeoff. We will create a ATC interface and have method register flight, which takes input flight to be registered. Let's create the flight class. And then we will have a registered runway and register whether a runway is available for landing. In the airport, there can be multiple runways. We will create a runway class. We'll come to this flight and runway class later. Something is wrong. Okay, it should be interface. Then we will have a method to set the ability of the runway and then get if it is available. We will have our implementation ATC class, which implements IATC interface. We'll override all the four methods and have private variable runway and flight, and available, which is of type boolean. In register flight, we will assign it to this.flight. And in register runway, we will assign runway to this.runway. And in set ability status, we will set available to either true or false depending on the current status. We will create a command interface and pass command like land. And in runway class, we will implement command interface. Override the land method. We'll create a ATC object, which is actually a mediator. And run constructor, we will pass ATC object and assign it to this.atc mediator. In land method, we will print runway is available for landing. And in ATC Mediator, we will set ability as true. Similarly, in flight class, we will implement command interface and override the land method. We will create a private ATC object and in flight constructor, we will override it and pass mediator and assign it to ATC Mediator. In the land method, we will first check with the mediator whether the runway is free. If yes, then land successfully. And in ATC Mediator, set ability to false so that no other flight can land until the current flight is moved to parking slot. If runway is not available, print waiting for runway. Next, we have a method ready to land and print landing initiated. And another method, park, and print flight is parked. And inform ATC that the runway is available. Now in client class, we will create a ATC object and then we will create a runway object and pass the ATC object to the constructor. Suppose a flight named Flight 1 asks the ATC for ability. ATC registers the flight, then ATC registers the runway, then the flight is ready to land. Flight.ready-to-land, runway.land, and flight.land. When we run the program, we can see that flight is able to land successfully. Now if a second flight comes, flight F2, and asks for landing before the flight 1 is parked, then it need to wait until the runway is free. What is happening behind the scene is when flight 1 tries to land, it checks with ATC, that is the mediator, and ATC confirms that runway is available. But when flight 2 tries to land, ATC responds back that the runway is not available and the flight 2 need to wait. But when flight 2 is moved to parking space, the runway is set to available and flight 2 can land successfully. This is a simple example to understand how to implement mediator design pattern. If the video is helpful, hit the like button. Subscribe for upcoming tutorials. Thanks for watching.